Hi guys, this is the second exercise of the assignment, and I'm going to do it. I'm going to play a PowerPoint. I prepared it for your exercise just to see how is the solution. Okay, let's start. So this is the PowerPoint. So this is the PowerPoint that I was going to show you. So in this is the second exercise. And maybe it's as simple as the first one, only in this case, as you can see from your printout, the force is in an angle. By being the force in an angle, we have to divide it. It's hard to find the distance because you know what is the distance perpendicular from here. Distance we want to find the moment about point B and A. The moment about point A, what is the distance? Distance is perpendicular from the point A to here. Imagine how complicated it is. Even from point B, the distance is going to be somewhere here. So it's not easy, but so in this case, as we have seen, we divide the force in two components. That's what I call good guy, bad guy. Good guy is the guy that is either horizontal or vertical. If the guy is bad, we're going to divide in two components. It's not given the angle, but what do we need the angle for? To have the sinus and cosinus is given 3, 4, and 5, the dimension of the angle. So if I have this one, those 3 dimensions, I can find the sinus and cosinus. Remember, horizontal projection is force times cosinus of this angle alpha. And vertical projection is force times sinus of this angle alpha. So, and that's why I take this force, separate, and you see the 20 kilonewton force is here. And let's see the two components. So this triangle, the triangle 3, 4, 5 is here, and this is the angle alpha. So of course, sinus alpha is 3 over 5. And cosinus alpha is 4 over 5. Therefore, the vertical component is force, which is 20 sinus alpha. I let you to make the calculation. And the horizontal component is 20 cosinus alpha. So they are very easy calculation. Therefore, when I am going to have the exercise now, no more bad guys. So I have the vertical component and the horizontal component. I did not put the result because this is your job. But now let's calculate the moment. Let's start from the difficult one. Moment about point A. You see this force about point A. What did we call distance? Distance we call perpendicular from the point to the direction of the force. This is the direction of the force. So the distance is 1.2 meters. And the rotation, as you can see, is clockwise, so it's negative. Let's see the horizontal component, the blue one. What we call distance? Distance we call perpendicular from the point to the direction of the force. This is the direction of the force, or this is the line of action for the force, and this is the distance. So the distance is 0.8. The distance is 0.8. So, and the rotation of the blue force is again clockwise, so both of them are negative. Let's go to the point B. The moment of this force about point B is 0. Many times, guys, I see this problem. You know, the student write force times 0.8 because they see this distance 0.8. Remember, I said many times, distance we're going to call the perpendicular from the point to the line of action from the force. And in this case, the point B is in the line of action from the force, so this force cannot rotate the point B. Cannot rotate, so the moment is 0. What is left? Only the horizontal force. How much is the distance? Distance is the same, 0.8. Remember what I told you before in the previous exercise. If the force is parallel with AB, the moment about every point, not only point A and B, but if we have another point C, somewhere here, the moment is going to be the same. So this one the distance 0.8 and this negative. That's it. You see, it's very easy. It's very good for you to practice on this exercise. Thank you very much. You see the mouse is happy as well. Thank you, guys.